All right, this is the video for lesson 2.3 that I want you to watch today. Today's an e-learning day, so hopefully all this stuff makes sense. If not, we can go over it when we get back to school in a couple days. Battling a fever, so I hope I can make it through this video okay. So it's been a rough couple days for me. All right, let's take a look at 2.3. First, lesson 2.2, we talked about qualitative data. Remember that qualitative data is not a number. It's like you have what color are your eyes, things like that. That's qualitative as opposed to quantitative data, which is what we're going to get into today. Then we talked about a frequency distribution and a relative frequency distribution. And we displayed these distributions with pie charts and bar charts, which is something that I hope you guys were able to do yesterday. Today, in this lesson, we're going to be talking about quantitative data. So quantitative data is data that you get, and it is a number. We're going to go through quite a bit of things to display this data, and then we'll be doing our Math Excel assignment. So data is often placed in categories or bins. And so these bins could be limited number categories. So in other words, you want to make sure that if you have, like, you can have 100 different numbers, you don't want to have 100 different bins. So you're going to put them in groups and maybe go from 0 to 25 and 26 to 50. And you don't want a lot of categories, but you want enough to distinguish a difference. Another principle is that each observation should fit a category. So you don't want to have a number that there is simply not a category for. So every number that you get in a survey should fit a category somewhere. And the category should be of equal length. You shouldn't have a category that goes from 0 to 2 and then another one that goes from 3 to 30. Okay, they should be of equal width. So the first type of grouping method is single value grouping, when categories are based on a single number. And so, for example, if you were asked the question, how many TVs do you have in your house? And people answered with these numbers here. You could display this in a frequency or relative frequency distribution chart by putting them into categories of just one number apiece. So one person has 0 TVs, there are 16 people who had just one TV, and so on. And here's the relative frequencies. So 0.2 would be the case because it's 1 out of 50. So another type of grouping method is limit grouping. So when categories are based on a whole number observation with a range for each group. So an example of that would be days to maturity for a 40 short-term investment. I'm not great on types of investments, but the answers that you can see here, it goes, I see as something as low as 38 and something as 36 even over here, and then as big as 83. And so we want to make sure that we're not going to have that many different groups, so we're going to put them into categories. And maybe the categories we pick are like this: 30 to 39, 40 to 49, and so on. And so those are our limit number grouping. And you could see that all of the numbers that were in our survey fall into one of these grouping categories. So there's going to be some terms that you're going to want to know when we talk about limit grouping. There's a lower class limit, which is the bottom of the group, and the upper class limit, which is the upper number in that group. The class width, so in this example, the class width was 10 because it went from like, they were separating them out by groups of 10. Excuse me. And then a class mark is the average between the lower and the upper limits. And then the third type of grouping method is called cut point grouping. And cut point grouping is what you use when the observations are continuous numbers. Okay, and so an example of that would be grades. And so I put this together for you. I do this at the end of every semester, but I try to figure out, am I giving a frequency of grades that is okay with me? And so last semester I had 4 students that had me as a teacher and got an F. 12 had D's, 21 had C's, 54 had B's, and 32 had A's. And so they say that your average should be a C, but at Homestead our average is a little bit more than a C. I would say our average is close to a B, at least with the classes that I've taught. Okay, and so this is an example of what we were talking about, where we have from 79.6 to 89.5 would be B's, 89.6 to 100 would be A's, and that's a continuous graph, a continuous response. All right, so terms when we talk about cut point grouping, kind of like our limit grouping, there's a lower class cut point and an upper class cut point. So that's like the lowest number in a group, the highest number in a group. The class width is just like the width in midpoint grouping or limit grouping, and then the class midpoint would be the average of the lowest and the upper classes. So those are our different grouping methods. So here's when we use each one. So we use single value grouping when there's a discrete data in which there are only a small number of distinct values. So number of TVs in your house. Okay, and then limit grouping is what we use when there's a wide range of values, but it's not continuous. You either have 1 or 2, but you don't have like 1.5. And then cut point grouping would be like your grades. You can have a 89% or a 90% or an 89.3% or an 89.4%. So those are the grouping methods. Now we're going to talk about how to display this data. And so the first way to display the data is the use of a histogram. And so a histogram is kind of like a bar graph. We put relative frequencies or percents or even frequencies on the vertical axis, and then we put each bar, the horizontal axis, represents the groups that we are going to be putting them in. And for single value grouping, we use the distinct values of the observation. For limit grouping or cut point grouping, we use the lower class limit. And then the bars touch each other. So that's different than in a bar graph, because in a bar graph, the bars didn't touch each other. We made them single bars where they didn't touch each other. So here are some steps on how to construct a histogram. But let's talk about what it would look like. So here we have two examples of histograms. One is a frequency histogram and one is a relative frequency histogram. And this is over the television sets per household. And so we had one person that had 0 TVs. We had 16 people that had 1 TV, and so on. And then the only difference between this graph and this graph is that this graph has the relative frequencies as opposed to the frequencies. And you can see that they put the 1 in here, which is the bottom. This is just 1 and 2 and 3 and so on of the number of TVs. All right, let's move on. Let's take a look at the limit grouping histograms. And so the limit grouping histograms, this was the short-term investments. And so all of them between 30 and 40 are in this bar. All of them between 40 and 50 are placed in this bar, and so on. And then it goes up to the frequency, which there were 3 here, and there were 1 here. And then the relative frequencies are over here. And you can see the bars are touching each other. That makes it a histogram as opposed to a bar graph. And then this final one is cut point grouping. Okay, I don't have one for my grades, but here is one for the weight of 18 to 24-year-old males. And so males that weigh between 120 and 140, there are 3 of them. In this survey, 140 to 160, looks like there were 9 of them, and so on. And so here's a relative frequency of what that looks like. So those are examples of histograms. Another way to display them is to use a dot plot. A dot plot is when each observation is plotted as a dot at an appropriate place above the horizontal axis. It looks something like this. So prices in dollars of 16 DVD players. So you have these 16 DVD players. One of them was, let's see, this must be $196, $199. And so there were 3 of them there. And so that is a dot plot. It kind of gives you a picture of where most of them fall between. And then the final one that we're going to be talking about is a stem and leaf plot, sometimes called the stem plot. And let's talk about what these are. So you have, here's the days to maturity of 40 short-term investments. You want to display this somehow. And so one way to display this is to have, this is called the stem, and this is the tens digit. So there's the 38, a 36, and a 39. And then there's a 47, and a 57, and a 51, and a 56. So you can kind of organize them by their first digit, and then you want to organize the ones digits in order. So instead of 71635105, you would have 00135567. So the smallest one would be 36 days, and then 38, 39, 47, 50, 51, 52, and so on. And that's a good way that is used quite often to organize data that's spread out into different categories. So here's another one that talks about cholesterol. So if you collect people's cholesterol, you can also put the first 2 digits, like 199 and 200 and 202 and so on. And so you can have the stem be 2 digits as opposed to just 1 digit. And that would be another way to create a stem and leaf plot for information. And that's what 2.3 is about. So after watching this video, you can work on assignment 2.3 in Math Excel, and we might be doing this again tomorrow. Have a good day, everybody.